Hello everyone, my name is G.naga Subrahmanyam. I am studying ECE at VVIT College Guntur. My roll number is 20BQ1A0456. Today our topic is about principles of green chemistry.
Principles of green chemistry. In these, we have 12 principles for the green chemistry. First one, pollution prevention. Second one, atom economy. Third one, less hazardous chemical synthesis. Fourth one, designing safer chemicals. Fifth one, safer solvents and auxiliaries. Sixth one, design for energy efficiency. Seventh one, use of renewable feedstocks. Eighth one, reducing derivatives. Ninth one, catalysis. 10th one, design for degradation. 11th one, real-time analysis for pollution prevention. 12th one, inheritance safer chemistry for accidental prevention. And the first one, we have the pollution prevention. Let me talk about it. First one, we have prevention is better than cure. In this pollution prevention, it is better to prevent waste than to treat or clean up waste after it is formed. An ounce of prevention is worth a pound of cure. A chemist in green chemistry lab is performing pollution prevention on a molecular level. Atom economy. Synthesis methods should be designed to be minimize the incorporation of all materials used in the process into the final product. Waste not, want not. A chemical reaction is formed as A plus B gives rise to C. That the cooking analysis gives ingredients in and out products out. Any byproducts. Where do products come from? The products came from the atoms, and the reaction of atoms gives us molecules, and that molecules combine to form a material, and that material gives us products. Here we see atoms gives molecules. And later, examples are atom economy, Diesel's-Elder reaction, 4 plus 2 cycloaddition. Is we add 1,3 butadiene with ethylene. We have the bonds between two carbon atoms will be arranged as cyclo, and we get cyclohexane. Like catalytic reaction, we have prop 1 ene react with hydrogen. Here the bond can be reacted with hydrogen and form prop 1 in 100% accuracy. We see the third one, less hazardous chemical synthesis. Whenever practicable, synthesis methodologies should be designed to use and generate substances that possess light or no toxicity to human health and the environment. When a chemist do chemistry, they have a choice in how they do it. Choosing the safer method in chemistry is like using a screwdriver instead of knife to twist a screw. The knife might be able to tighten the screw, but it's dangerous to tighten a screw. Later, we see a reaction of a traditional pathway, highly hazardous method. Traditional or conventional method for synthesis of adipic acid uses cationic benzene as a starting material. Here we take a benzene which is carcinogenic, can be reacted with hydrogen with the catalyst Ni. We get a catalytic reaction and form a cyclohexane. And these cyclohexane will react with the concentrated HNO3 in the presence of concentrated H2SO4. We have cyclohexanol or cyclohexane. These reaction can be reacted with the concentrated HNO3, and further for oxidation we get cyclohexane or 1,2 dione. Here these will be reacted with we get adipic acid 40%. And green pathway or green synthesis, the most common used in green procedure for synthesis of adipic acid, uses cyclohexane as the starting material. Here we have the cyclohexane as the starting material, which is reacted with NaNO4 and H2O2. We get adipic acid 100% yield. And later for that another reaction we have D-glucose can be reacted with ethyl benzene. We get cis mucanic acid which is reacted with H2. We get adipic acid 95% yield. Adipic acid can be formed for us. Later, synthesis of polycarbonate, traditional pathway. The traditional route for the synthesis of polycarbonate uses phosgene as the starting material, which is highly toxic. Here we take bisphenol A reacts with polyene. We, in the presence of zinc and HCl, we get polycarbonate, and like that we add bisphenol A with diphenol carbonate, we get carbonate. Here we see the fourth one, designing safer chemicals. A chemical product should be designed to prevent efficacy of the function while reducing toxicity. Chemists are molecule designers. They design new molecules and new materials. Green chemists make sure that the things that we make not only do what they are supposed to do, but they do it safely. This means that it's not only important how chemists make something, it's almost important that what they make it's harmful. Making safe, non-toxic products is the goal of the chemists of the green chemistry. One, safer solvents and auxiliaries. They use the auxiliary substances like solvents, separation agents, etc. should be made unnecessarily whenever possible and when used unconscious. Many solvents are hazardous and toxic. There are safer alternatives for the solvents. We have some green solvents like water, supercritical water at 647 Kelvin and 218 atmosphere, and supercritical CO2 at 340 Kelvin and 74 atmosphere. Later, ionic liquids like ethane ammonium nitrate, N-pyridinium tetrafluoroborate. Here we see the sixth one, designing for energy efficiency. Energy requirement should be recognized for their environment and economic impacts and should be minimized. Synthesis method should be conducted at ambient temperature and pressure. Chemists also use a lot of energy like heating, drying and cooling. Energy is not only expensive. Most of the time the power plant of the creates the energy contributes of pollution. Seventh one, use of renewable feedstocks. A raw material or feedstock should be renewable rather than developing whatever technically and economically practical. Green chemists look at alternative sources for making materials. Renewable feedstocks like corn, potatoes, biomass can be used to make many products like fuels, plastics and more. Here, for example, we take a corn, it can be converted into starch and later it will be get as lactic acid, and these lactic acid further go polylactic acid and that gives roll stock and multi packets. Fifth one, reducing derivatives. Unnecessary derivatives should be avoided whenever possible, like blocking of groups production and deproduction, temperature modifier of physical and chemical processes. Later, ninth one, catalytic reagents. Catalytic reagents are superior to stoichiometric reagents. Like in chemistry and biology, catalysts make a key role for the completing the reaction without any byproducts. Like that, catalyte is a acceleration of chemical reaction by means a substance called catalyst, which itself not consumed all over reaction. It reduces and byproduct formation. 10th one, design for degradation. Chemical products should be designed so that at the end of their function they do not persist in the environment and instead break down into unconscious degradation. Recycling is one way of reducing waste, but we cannot recycle everything. What happens when we throw away things? Design for degradation means that when green chemists design a new chemical or material like a paracetamol drug or medicine that is a new plastic, they design it so it breaks down at the end of the useful lifetime. And 11th one, real-time analysis for pollution prevention. Analytic methodologies needs to be further development to allow their real-time in-process monitoring and controlling prior to the formation of hazardous substances. Real-time analysis for a green chemist is the process of checking the progress of chemical reaction as it happens. Knowing when our product is done can solve a lot of waste, time and energy. 12th one, inherently safer chemistry for accident prevention. Substance and the formation of substance used in the chemical process should be chosen so as to minimize the potential for chemical accidents, including releases, explosions, and fire. In 1984, we have a Bhopal disaster. 1984, the methyl isocyanate are accidentally released when a tanking hold tank overheated at the Union Carbide pesticide plant located in the center of Bhopal. So many people, nearly 15,000 people died and hundred thousands of people were injured. Chemists try to avoid things that explode, light on fire or air sensitive etc. In real world, when these things happen, lives are lost. Thanks for watching.